This video is about secant, cosecant, and cotangent. This is AP Precalculus topic 3.11. If you appreciate this content, please give it a like. Number 1. Let f of x equal the secant of 1/2 x. Which of the following is a vertical asymptote on the graph of f? I'm putting this in a thought bubble because this is not something you need to write down, but you should be thinking the secant of 1/2 x is equal to 1 over the cosine of 1/2 x. A vertical asymptote will occur wherever the secant of 1/2 x is undefined. In other words, wherever the denominator, cosine of 1/2 x, is equal to 0. Therefore, to find the vertical asymptotes, we need to solve the equation cosine of 1/2 x is equal to 0. First, we solve for 1/2 x by asking ourselves the cosine of what is equal to 0. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. So the first two solutions for 1/2 x are pi over 2 and 3 pi over 2. We can get x by itself by multiplying both sides of the equation by 2. Multiplying 1/2 x by 2 gives just x, and multiplying pi over 2 and 3 pi over 2 by 2 leaves pi and 3 pi. Let's see if any of these solutions are among the answer choices. We see pi right there, so the answer is D. Number 2. In the xy plane, the graph of which of the following functions has a vertical asymptote at x equals pi over 2? Looking at option A, we know that cosecant x is 1 over sine x. So this function will have a vertical asymptote where the denominator, sine x, is equal to 0. On the unit circle, sine is the y value, and y values are equal to 0 here and here. That's at 0 and pi, not pi over 2. So A is not the answer. Looking at option B, we think cosecant of 2x is equivalent to 1 over the sine of 2x. So this function will have a vertical asymptote where the denominator, sine 2x, is equal to 0. First, we solve for 2x by asking ourselves the sine of what is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 here and here. So 2x might equal 0 or pi. Next, we can isolate the x by dividing both sides by 2. So dividing by 2 on the left gives us x. 0 divided by 2 is still 0, and pi divided by 2 is pi over 2. We were looking for the function that has a vertical asymptote at x equals pi over 2, and we just found that cosecant of 2x has a vertical asymptote at 0 and pi over 2. So the answer is B. Number 3. In the xy plane, the graph of which of the following functions has a vertical asymptote at x equals 2? For option A, we think the cosecant of 1/2 x is equivalent to 1 over the sine of 1/2 x. So this function will have a vertical asymptote where the denominator, sine of 1/2 x, is equal to 0. The vertical asymptotes will be the solutions to this equation. We begin by solving for 1/2 x by asking ourselves the sine of what is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 here and here. That's at 0 and pi. We can isolate the x by multiplying both sides of the equation by 2. This gives us x equals 0 and then 2 pi. These are the first two solutions. We are skipping right over x equals 2. Remember that pi is approximately 3.14. So 2 pi is approximately 6.28. So we go from the solutions 0 and 6.28, nowhere near 2. So the answer is not A. For option B, we are thinking the cosecant of 2x is equal to 1 over the sine of 2x. This function will have a vertical asymptote where the denominator, sine of 2x, is equal to 0. So the vertical asymptotes will be the solutions to this equation. We begin by solving for 2x by asking ourselves the sine of what is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 here and here. So 2x will equal 0 or pi. We can isolate that x by dividing both sides by 2. This gives x is equal to 0 or pi over 2. We are not getting x equals 2, so B is not the answer. For option C, we think the secant of pi x is equal to 1 over the cosine of pi x. This function will have a vertical asymptote where the denominator, cosine pi x, is equal to 0. In other words, the vertical asymptotes will be the solutions to this equation. First, we solve for pi x by asking ourselves the cosine of what is equal to 0. On the unit circle, cosine is the x value, and x values are equal to 0 here and here. So pi x will equal pi over 2 or 3 pi over 2. There are infinitely many solutions actually, but these are the first two. We can isolate this x by dividing both sides by pi. On the left, if we divide by pi, the pi's cancel out. On the right, when we divide by pi, this pi will be in the denominator for a quick second. And then, on the right-hand side, we're going to get x is equal to. These pi's cancel out, leaving 1/2, and these pi's cancel out, leaving 3 over 2. We were looking for x equals 2. So we are not getting x equals 2, so C is not the answer. For option D, we are thinking the secant of pi over 4x is equal to 1 over the cosine of pi over 4x. This function will have a vertical asymptote where the denominator, cosine of pi over 4x, is equal to 0. So the vertical asymptotes for this function will be the solutions to this equation. First, we solve for pi over 4x by asking ourselves the cosine of what is equal to 0. Cosine is the x value on the unit circle, and the x values are equal to 0 here and here. So pi over 4 will equal pi over 2 or 3 pi over 2. We can isolate the x by multiplying by the reciprocal right here. So we will multiply everything through by 4 over pi. On the left side, the 4's and the pi's cancel each other out, leaving just x. Then, on the right-hand side, these pi's cancel each other out, leaving 4 over 2, which is 2. Next, these pi's cancel each other out, leaving 4 times 3, which is 12, divided by 2, which is 6. So, we just found that this function has vertical asymptotes at x equals 2 and x equals 6. We were looking for the function that has a vertical asymptote at x equals 2, and we have found it. So the answer is D. Number 4. Let g of x equal the cotangent of 2x. Which of the following is a vertical asymptote on the graph of g? We should be thinking the cotangent of 2x is equal to the cosine of 2x divided by the sine of 2x. This function will have vertical asymptotes wherever the denominator, sine of 2x, is equal to 0. The vertical asymptotes will be the solutions to this equation. First, we find 2x by asking ourselves the sine of what is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 here and here. So 2x will equal 0 or pi. Dividing both sides of the equation by 2, we get x is equal to 0 or pi over 2. So x equals pi over 2 is a vertical asymptote. So the answer is D. Number 5. Let h of x equal 3 times the secant of 4x plus 1. Which of the following statements about the graph of h is correct? All of these answer choices give equations for the infinitely many vertical asymptotes of h of x. Vertical dilations and vertical translations do not affect the location of vertical asymptotes, so we can ignore the 3 and the 1. We know that the secant of 4x is equal to 1 over the cosine of 4x. This function will have vertical asymptotes wherever the denominator, cosine 4x, is equal to 0. We can find all of the vertical asymptotes by finding all of the solutions to this equation. First, solve for 4x by asking yourself, cosine of what is equal to 0? Cosine is the x value on the unit circle, and x values are equal to 0 here and here. Well, these are the first two solutions. We can find infinitely many solutions by continuing to go around the unit circle. But let's start with pi over 2 and 3 pi over 2. Or rather, let's not list out the pi over 2 and the 3 pi over 2. Once we have the pi over 2, we can go infinite by asking ourselves, well, how far do we have to go to get to the next solution? We can get from pi over 2 to 3 pi over 2 by adding pi. We can get to the next solution by adding pi again. In fact, we will get another solution every time we add pi. So we will get all of the solutions by adding multiples of pi. In other words, by adding pi k, where k is any integer. We can isolate the x by dividing both sides of the equation by 4. When you divide pi over 2 by 4, you're going to get the extra 4 in the denominator like this. When I divide this by 4, it'll just be pi over 4k. So on the next line, we have x is equal to pi over 8 plus pi over 4k. So the answer is A. The graph of h has vertical asymptotes when x is equal to pi over 8 plus pi over 4k, where k is any integer. Number 6. Let h of x equal 5 times the secant of 1/2 x. Which of the following gives the range of h? On a previous video, we learned that the parent function secant x has the range -infinity to -1 and 1 to infinity. Focus on these key y values, -1 and +1. Let's see how the transformations that bring us h of x affect these key y values. The only transformation that will affect the y values is the vertical dilation by a factor of 5. So the new y values will be 5 times the original y values. That's 5 and -5. So for the range, instead of going from -infinity to -1, union 1 to infinity, the new range will go from -infinity to -5, union 5 to infinity. So the answer is B. Number 7. Let k of x equal 4 times the cosecant of 2x minus 1. Which of the following gives the range of k? Remember that the range of the parent function cosecant x goes from -infinity to -1, union 1 to infinity. So focus on the key y values of -1 and +1. Let's see how the transformations that bring us k of x affect these key y values. The only transformations that affect y values are the ones on the outside of the trig function, the vertical dilation by a factor of 4, and the vertical translation by -1. So the new y values will be 4y minus 1. 4 times 1 is 4, minus 1 is 3. 4 times negative 1 is negative 4, minus 1 is negative 5. So, instead of the range going from negative infinity to negative 1, union 1 to infinity, the new range will go from negative infinity to negative 5, union 3 to infinity. That's why the answer is C. Number 8. Let f of x equal 2 times the secant of x minus 5, and g of x is equal to negative 1. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of f and g for 0 is less than or equal to x, which is less than 2 pi? The intersection points will be where function f is equal to function g, so the intersection x values will be the solutions to the equation secant x minus 5 is equal to negative 1. Let's start by isolating the trig function. Adding 5 to both sides, we get 2 times the secant of x is equal to 4. Dividing both sides by 2, we get the secant of x is equal to 2. The reciprocal of secant is cosine, so we can take the reciprocal of both sides of this equation and get cosine x is equal to 1/2, the reciprocal of 2. We can solve this equation by asking ourselves the cosine of what is equal to 1/2. If you have not yet memorized these 9 trig values, pause the video and memorize this chart right now. So, assuming you've memorized this chart, you know that the cosine of pi over 3 is 1/2. So that tells you that the reference angle is pi over 3. Again, the fact that the cosine of pi over 3 is equal to 1/2 just tells us that the reference angle is pi over 3. The reference angle is the angle between the terminal side and the x-axis. Between 0 and 2 pi, there are 4 angles with a reference angle of pi over 3. There's one in every quadrant. These angles are special because the cosine of any of these angles will give us some kind of 1/2. It's just that 2 of them will give us positive 1/2, and 2 of them will give us negative 1/2. In this case, we want the angles that give us positive 1/2 when you take the cosine. Cosine is the x value on the unit circle, and x values are positive in quadrants 1 and 4, the right-hand side, to the right of the y-axis. So we can safely ignore the angles in quadrants 2 and 3. The angle in quadrant 1 with a reference angle of pi over 3 is pi over 3 itself. So that's one solution. The angle in quadrant 4 that has a reference angle of pi over 3, well, what is that called? This angle right here is pi, but looking at the reference angle, we can think of it as 3 pi over 3. Doubling this, we can think of 2 pi as 6 pi over 3. Therefore, this angle will be pi over 3 less than 6 pi over 3, making it 5 pi over 3. So that's the other solution. So these are the x-coordinates of the intersection points of functions f and g between 0 and 2 pi. Number 9. Let h of x equal 2 minus 3 cosecant x and k of x equals 5. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of h and k between 0 and 2 pi? The intersection points will be where h of x and k of x are equal. So we can find these intersection points by solving the equation 2 minus 3 cosecant x equals 5. Let's start by subtracting 2 from both sides. That gives negative 3 cosecant x is equal to 3. We will isolate this trig function by dividing both sides by negative 3. that leaves the cosecant of x is equal to -1. Cosecant is the reciprocal of the sine function. So if we take the reciprocal of both sides of this equation, the reciprocal of cosecant x is sine x, and the reciprocal of -1 is still -1. -1 is like -1 over 1. So the reciprocal would be 1 over -1, which is still just -1. We can solve this equation by asking ourselves the sign of what is equal to -1. On the unit circle, sine is the y value, and the y values are equal to 0 here, 1 here, 0 here, and -1 right here. So this is 3 pi over 2. This is the only solution to this equation on the interval from 0 to 2 pi. So this is the x-coordinate of the only intersection point between function h and function k. Number 10. Let m of x equal 3 times cosecant squared x minus 2, and p of x equals 2. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of m and p between 0 and 2 pi? The intersection points will occur where m of x is equal to p of x. So we can find the x-coordinates of these intersection points by setting 3 cosecant squared x minus 2 equal to 2 and solving. Adding 2 to both sides, we get 3 cosecant squared x is equal to 4. Dividing both sides by 3, we get cosecant squared x is equal to 4 over 3. We can get rid of the squared part by taking the square root of both sides of this equation. The square root of cosecant squared is just cosecant x. And on the right side, we will have plus or minus, and when you take the square root of a fraction, you take the square root of the numerator and denominator separately. So the square root of 4 is 2, and then in the denominator we have the square root of 3. Now let's take the reciprocal of both sides of this equation. The reciprocal of cosecant is sine. So on the left side we have the sine of x equals plus or minus, and of course the reciprocal of 2 over radical 3 is radical 3 over 2. We can find the reference angle by asking ourselves the sine of what is radical 3 over 2. Remember those 9 trig values that we have memorized. We know that the sine of pi over 3 is radical 3 over 2. So pi over 3 is the reference angle. Every quadrant has an angle with a reference angle of pi over 3. These angles are special because the sine of any of these angles will give us some kind of radical 3 over 2. It's just that 2 of them will give us positive radical 3 over 2, and 2 of them will give us negative radical 3 over 2. But in this case, we want positive and negative radical 3 over 2. So all 4 of these angles will be solutions. In the first quadrant, the angle that has a reference angle of pi over 3 is pi over 3 itself. But what about in the second quadrant? Well, pi is right here, and looking at the reference angle, we can think of it as 3 pi over 3. Therefore, this angle in the second quadrant will be pi over 3 less than 3 pi over 3. That's 2 pi over 3. That's another solution. In the third quadrant, we are pi over 3 more than 3 pi over 3. That's 4 pi over 3. That's another solution. Then, if we double this, we can think of 2 pi as 6 pi over 3. So this angle is pi over 3 less than 6 pi over 3, which is 5 pi over 3. So these are the x-coordinates of all of the intersection points of function m and function p on the interval from 0 to 2 pi. This last problem is calculator active. Let f of x equal 2 plus 3.1 times the cotangent of 0.3x plus 5. In the xy plane, what are the x-coordinates of the points where f of x is equal to -6 on the interval from 0 to 2 pi? In other words, we need to set f of x equal to -6 and solve. We can use the graphing calculator to solve equations like this by entering the left side of the equation as y1 and entering the right side of the equation as y2. Right here is where I want to write cotangent. However, there is no cotangent button on the calculator, only a tangent button. So I have two choices. I can either enter cotangent as 1 over tangent, or I can type in tangent and then raise it to the -1 power, which means the same thing. Notice that this blue tangent with a -1 over it does not mean 1 over tangent. This means arctangent or inverse tangent, which is something completely different. So don't hit second tangent and use that. Anyway, so we need, what was it, -6 on y2? Yeah. So the solutions to this equation will be the intersection between y1 and y2. Before we hit graph to find the intersection point, let's adjust the window. Remember, the domain is limited, 0 to 2 pi. So I see the 0 there, and so x max should be 2 pi. For y min, let's do -10 for now. We can always adjust later. And for y max, let's do +10. Now hit graph. So we see the one intersection point right here. We can find it by doing second, trace, and choosing option 5 for intersect. Move the pointer close to the point of intersection and hit enter 3 times. Enter, enter, enter. So there is the solution. It doesn't matter on this problem because the last decimal is a 0, but I want to remind you that it's a good idea to always use 4 decimal places and don't try to round, even though the College Board will accept 3 decimal places. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.